Welcome to the session on modelling in mechanics, constructing a model. The objectives for this session are to understand how the concept of a mathematical model is applied to mechanics. Mechanics explores motion and how forces act on objects. Real-life scenarios are simulated by constructing mathematical models. It can be necessary to simplify problems by making assumptions to make the problems easier to work with. Sometimes the model may need to be refined. Let's take a look at the process of mathematical modelling. We begin with a real-life problem. Then we create maths models, or a maths model. We specify the assumptions and the variables. Next, we solve and interpret it. And then ask ourselves, is the answer reasonable? If it is, then we present the solution. However, if it's not, then we need to reconsider and go back to the creating the mathematical model stage and through all the subsequent points or the subsequent steps. Let's now take a look at an example. A golf ball is struck by a golfer. It takes the form of a parabola, as you can see. The motion of the ball can be modelled using the equation h equals 0.25x minus 0.05x squared, where h is the height of the ball above the ground and x is the horizontal distance travelled by the ball in meters. So for example, if the ball is here as shown in the diagram, we have the height h as denoted here and the horizontal distance x as denoted here. We are firstly required to find the height of the golf ball when it is released at a horizontal distance of 1 meters. And secondly, we are asked what is h when x is 10 meters, and is this prediction valid? So let's have a look at example 1a first. We are required to find the height of the golf ball when it is released at a horizontal distance of 1 meters. So when x equals 1, we plug in x equals 1 into the formula for h, as shown here. So we have h equals 0.25 times 1 minus 0.05 times 1 squared. And of course we've plugged in x equals 1 here and here to give us h equals 0.2. Therefore, when x equals 1 meter, we have that h equals 0.2 meters. And now for part B. What is h when x equals 10 meters? Is this prediction valid? When x equals 10, we plug that into the equation for h, as shown here. And of course, x equals 10 has been plugged in here and here to give us that h equals minus 2.5. So when x equals 10, h is equal to minus 2.5. We need to ask ourselves, is this prediction valid? Of course, height cannot be negative, so the model is not valid when x equals 10 meters. This brings us to the end of this session. If you have understood its contents, you should be able to understand how the concept of a mathematical model is applied to mechanics. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.